The 1996 Canadian Open Mathematics Challenge. The roots of the equation x squared plus 4x minus 5 equals 0 are also the roots of the equation 2x to the power 3 plus 9x squared minus 6x minus 5 is equal to 0. What is the third root of the second equation? Well, the first one right here, that one we can factor out pretty easily. X squared plus 4x minus 5 is equal to 0. And that, of course, will factor pretty easily into x plus 5 and x minus 1. Now, we can easily figure out here that the roots are minus 5 and 1. So they're basically saying that this second equation also has the same roots, but it has an additional root, a third root, and that's what we have to figure out. So if these are the roots of the second equation, that means that this second equation, which is 2x to the power of 3 plus 9x squared minus 6x minus 5 is equal to 0, can be factored as x plus 5 and x minus 1, since those are the roots. And that's going to be equal to 0. But there's also going to be a third root, and that is what we have to concentrate on. Now, we don't know what it is, so I'll just call it ax plus b, some coefficients a and b, and we have to figure that out. So let's expand this guy here, and let's see what we get. Now, if we expand this, we will basically have a situation where we've got this x squared plus 4x minus 5, just like before, but then we've got this ax plus b, and that all equals 0. Keep expanding, and we got ax to the power of 3 plus bx squared plus 4ax squared plus 4bx minus 5ax minus 5b. And that equals 0. And then we can collect like terms, and when we do, we get ax to the power of 3 plus, if we put everything in front of the x squared, we'll have b plus 4a. And then if we put everything in front of the x, that coefficient is going to be 4b minus 5a. And then we've got this lone minus 5b, and that all equals 0. Correct? Okay, great. All right, now what we can do is just compare this guy up here to this guy. It should be identical. So that means that this coefficient has got to be the same as that coefficient. So immediately we can conclude that a is equal to 2. And then make our life easy, let's just go to the last one. We can conclude that this guy is the same as this guy up here. So that means that minus 5b is equal to minus 5, and therefore b is 1. So that means this is really just 2x plus 1. And therefore this gives us the third root, which would be 2x plus 1 is equal to 0, and therefore x is equal to negative 1/2. The numbers a, b, c are the digits of a 3-digit number, which satisfy 49a plus 7b plus c is equal to 286. What is the 3-digit number 100a plus 10b plus c? We are given that 49a plus 7b plus c is equal to 286. All right, so we got to do a little bit of fiddling around and see what we can come up with. So all of this has to equal 286, right? So let's just see. 286, I've got to multiply 49 by something. So let's just divide 286 by 49 just to see what kind of number I get. And this symbol that I've just drawn is the integer value, the largest integer value. And that's a 5. If you did this, you can do this in your head. You don't even need a calculator. So I'm going to deduce that perhaps this a is a 5. All right, let's just keep going. If it is indeed a 5, that means 49 times 5 is 245, and therefore this part this 49 times 5 basically gives me 245. So this has got to give me the remainder, which is 286 minus 245, right? And that's 41. So this has to be equal to 41. Okay, let's see what we can get. 41, I've got to multiply 7 times b. So let's divide 41 by 7. Let's see what we get as an integer. Again, you can do that in your head pretty quickly. It's a 5. So I conclude that this b is probably a 5. So that means this would be 7 times 5. And that 7 times 5 is 35. So now 245 plus 35 is 280. So that means this c has to be a 6. And if it is, this will all add up. So there we go. I just concluded that my a is a 5, my b is a 5, and my c is a 6. And you can easily verify that like I did there. So now we go back up here, and we got to figure out 100a plus 10b plus c. And that shouldn't be a problem. 100a is 5. 10b, b is 5, and then c is just a lone 6, so that looks like 500 plus 50 plus 6, and that is 556. The answer for number 2. The vertices of a right-angled triangle are on a circle of radius r, and the sides of the triangle are tangent to another circle of radius small r. If the lengths of the sides are about the right angle are 16 and 30, determine the value of big R plus small r. Well, let's do some labeling first. We've got to draw in some radii. So here's a couple, and let's try to draw them in so that they all sort of meet at the center point. And these are all tangents, so these are going to be right angles like that. And this is, of course, R, R, and R. And we are told that the sides are 16 and 30, right? So that means this is R from here to here, and therefore from here to here would be 30 minus R. 30 minus R. And in a very similar way, from here to here is R. Squeeze that in there. So that means from there to there would be 16 minus R. 16 minus R. From here to here, right there. Okay, so now we've got a couple rules that we have to implement. The first is that anytime you have a circle, and if you were to draw the diameter of the circle, and then inside you drew a triangle, if this is the diameter, this has to be a right angle. Now what they've done in this question is kind of gone reverse, that they've already told you that this is a right angle right there in the question stem. So you know that this is a right angle right here. Right there, that's a right angle. And that helps us tremendously, I think, in this question, because it helps you figure out that this is the radius times 2, the diameter, right? If this is a right angle, then that means that must be the diameter right there. So the diameter is, of course, equal to 2r. Okay, now one final piece of the puzzle that will help you figure this out is you draw two lines from the center of the circle to the edge of the triangle, like that, and like this. And then we have a property, of course, that if you have any point, let's say this point right here, that point right there, and you draw from it a line to a tangent point, so for example from there to there, and then you do the same thing from the same point, you draw another line to the tangent point, those two lines will have equal length, like that. And in a very similar way on this side of the diagram, you draw a line from, say, that point to a tangent point, which is right there. This is the tangent point. And then draw another line from that point to the next tangent point. Those two will also have equal length. Okay, so that basically means that this 2r, this segment of it is 16 minus r, and this segment of it is 30 minus r, right? Because they're equivalent to this guy and this guy. All right, so hopefully that's not too messy. So mathematically, what that means is that 16 minus r plus 30 minus r is equal to 2r. So do this math, and we get 46 minus 2r, 2 small r that is equal to 2 big R. That means 46 is equal to 2 big R plus 2 small r. Divide through by 2, and you get 23 is equal to big R plus small r. And there you go. That's what they wanted in the question. Determine the value of big R plus small r. Determine the smallest positive integer n which satisfies the equation n to the power of 3 plus 2n squared is equal to b, where b is the square of an odd integer. All right. So we have n to the power of 3 plus 2n squared plus is equal to b. And b is the square of an odd integer. Well, all odd integers are of the form 2x plus 1, and they're saying it's a square. Okay, so b is of that form. So therefore, n to the power of 3 plus 2n squared is equal to 2x plus 1 all squared. Okay, well, where do I go from here? I guess the only thing I can do is just expand it out. But perhaps that may not help me that much, so what I'm going to do is factor out an n squared on this side. And if I do, I get n plus 2. And that is equal to 2x plus 1 all squared. Now what we have to do is sort of think about this a little bit. This side is a perfect square, right? It's something squared. That means this side must also be a perfect square in order for things to match up, because they're equal. Okay, well, this is already a perfect square. It's n squared. So therefore, this right here must be a perfect square. Has to be. This has to be a perfect square. Okay, so let's figure out what type of value of n I can put in to make it a perfect square. Okay, how about, well, it's saying that n is a positive integer, so I got to start with at least 1. If I put 1, this becomes 3. 3 is not a perfect square. But if I put n equal to 2, then this becomes 4, and 4 is indeed a perfect square. Okay, that's my first guess as to what n is. But we got to see if this matches up. We got to ensure that b is the square of an odd integer. Okay, let's see what happens. So if n is 2, this becomes 2 squared times 2 plus 2, and that is 4 times 4, which is 16. And therefore b is equal to 16. Is 16 the square of an odd integer? Well, b is equal to 16, which is 4 squared. It's the square of 4. Is 4 an odd integer? No, it is not. Okay, well, that's a pretty good attempt, but it was wrong, so we got to keep going. Okay, the next perfect square that we can create is when n is equal to 7. When n is equal to 7, then this becomes 9, correct? So let's see what happens with our b this time. If n is 7, this is 7 squared times 9, and that is equal to 49 times 9, which is 441, and that is my b. What is 441? That's 21 squared. Is 21 an odd integer? The answer is yes. So this all matches up, and it does so for n equals 7. And they wanted the smallest positive integer n, so we don't need to keep going here because we got one that works. So there you go. Number 4, the answer is n equal to 7. A road map of Grid City is shown in the diagram. The perimeter of the park is a road, but there is no road through the park. How many different shortest road routes are there from point A to point B? The key word in this question is shortest, and you'll see later on why that is the key word. So what I'm going to do first is label a couple of key points. This point right here, which I will label x, and this point right here, which I will label y. X and y. And then because of the symmetry of this diagram, we can also label this guy y and this guy x. And we will see that first we'll deal with going up and across to the right. And then because of the symmetry of the diagram, if we can figure out the number of cases of going up, it will be equivalent or identical to the number of cases going in this direction, which is right, and then back up this way. So let's first deal with the first direction. Now, we want the shortest route from A to X. So, well, I believe that there's only 5 ways of doing that. There's one straight across like that. Then here's another one. That's 2. Here's another one. That's 3. Here's another one. That's 4. And finally, here's one. That's 5. Now, you might think, well, there's other ways of going there. For example, you could go like this or like that. But remember, that is not the shortest way anymore. You're adding additional steps. They want the absolute shortest way of getting from A to B. So there's only 5, like I illustrated. Once you get to X, there's only one way to go to B. Once you're here at X, there's only one way to go to B, and that's straight across. Now, you might be able to find other ways, like go down and come back up and then go down, but this is not the shortest way. And remember, that, in my opinion, was the key to the question, is concentrating on that word, shortest. So once you go to X, there's only one way to go to B. Okay, great. So now we have to figure out how to get from A to Y. Well, let's see. If I go from A up here, well, that's not a shortest route. So that one is disqualified because we're making unnecessary steps by doing it. But this way is the shortest route. So that's 1. And then this would be 2. This would be 3. And then this would be 4, like that. This would be 5. And this would be 6. And then I believe this would make me 7. This would be 8, 9, and finally 10. So hopefully I was able to illustrate that there's 10 shortest routes from A to Y. All right. So once you get to B, once you get to Y right here, from that point, there's 5 routes to B. And those 5 routes, here's 1, here's 2, here's the 3rd way, here's the 4th way, and here's the 5th way, all the way across like that. Okay, so now let's add all this up. From the first part, 5 shortest routes from A to X, then from X, only 1 shortest way to go to B, so that gives me a total of 5 routes, right? 5 times 1. And then from here, there's 10 shortest routes from A to Y, and then once you get to Y, there's 5 routes to B. So it's 10 times 5, which is 50. So 5 plus the 50 gives me my total, which is 55. But remember, that's half of the diagram. The other half are these X and Y's. And because of the symmetry of the diagram, they're going to be the exact same conversation. So it would essentially be another 55 going in that direction, if you're going this way or if you're going up to Y, that kind of thing. So 55 plus 55, the grand total is 110. Shortest different road routes from point A to point B. In a 14-team baseball league, each team played each of the other teams 10 times. At the end of the season, the number of games won by each team differed from those won by the team that immediately followed it by the same amount. Determine the greatest number of games the last place team could have won, assuming that no ties were allowed. So we have a situation where we have 14 teams. I'll label them A, B, and so on. So there's 14 of them, so we're going to go ... all the way down to the last few, K, L, M, N. So A, B, C, D, E, F, G, H, I, J, K, L, M, N. Those 14 teams. Now, what's interesting is that they're saying that each team plays the other team 10 times. So for example, A will play B 10 times. A will play C 10 times, and so on. So that means A will play 130 games, right? Because A is one team, there's 13 other teams. So for each of those 13 other teams, A plays them 10 times. So total, A plays 130 games, correct? 130 times. Now, what is true is that that kind of holds true for all the teams, right? And there's 14 teams. So there'd be 14 times 130 games, which is 1820. But you got to be a little careful because what we've done is we double counted here because all the teams, for example, are going to be counted twice with this 1820 because BA is the same as AB. If B is playing A, that's the same as A playing B. So because we double counted, we've got to divide this 1820 by 2. And that gives me 910. And that's the total number of unique games. All right. Well, we've got the total number of unique games. And then they're saying that the number of games won has this kind of unique pattern that it differs by the same amount. So, for example, if the number of games won by N is A, the number of games won by M would be A plus D. The number of games won by L would be A plus 2D. The number of games won by K would be A plus 3D. So as you can see, this is forming an arithmetic sequence. And many of you are familiar with arithmetic sequences. So what we have to figure out is what are these numbers. And eventually all the way up at the top it'll be A plus 13D. Okay? Well, there's no ties, so every game is going to have a win and a loss. So if there's 910 games, there's going to be 910 wins. So that means if you add up all these guys, it's got to equal 910. Correct? So that means A plus D plus A plus 2D plus A plus 3D and so on, ... all the way to A plus 13D. All of that has to equal 910. Okay, so this is an arithmetic sequence, pretty easy. How many A's do we have? We got 14 A's. And then we've got to add up D plus 2D all the way up to 13D. And you guys remember that formula, N times N plus 1 divided by 2 when you're adding consecutive numbers. And in this case, you're adding consecutive numbers from 1 to 13. So it would be 13 times 14 divided by 2. Don't forget the D. And that is 910. So this is 14A plus 91D is equal to 910. Okay, now at this point, you just got to make a little table and try to figure out what values work. And now we're just trying to figure out integer solutions to this equation right here. Okay, where do we begin here? Well, the difference, D, has to be at least 1, right? I mean, it can't be 0, because if the difference was 0, then it all had the same, all of these numbers would be the same, and they're not all the same, right? So let's start with D equals to 1 and see what we get. If D is 1, you sub it back into this equation, you get a value of A of 58.5. Now, that doesn't make sense because remember, A represents the number of games won by N, and therefore A must be an integer. So if A is an integer, then obviously it can't be 58.5. All right, keep going. let's try d equals 2. If d is 2, and you plug it into this equation right here, and solve for a, you get 52. Okay, that works. Let's keep going. If d is 3, and you plug it back into that equation, you get 45.5. That's invalid because you cannot have 45.5 games. It has to be an integer. Let's keep going. For a value of d, you get 39. And that is valid. Now you say, well, I've got two values here. Which one do I choose? And I probably will get more. Well, they want the greatest number. Remember, the question says, determine the greatest number of games the last place team could have won. Right here. Determine the greatest number of games the last place team could have won. So since you just want the greatest, we've already got 52. And it seems like these numbers are going to get smaller and smaller. So the answer to this question is 52. Triangle ABC is a right angled at A. The circle with center A and radius AB cuts BC and AC internally at D and E respectively. If BD is 20 and DC is 16, determine AC squared. All right, well, I'm going to have to draw a few lines here. The first one is from A to D, and that just represents the radius of the circle. A to B is a radius, so that means right off the bat that this is an isosceles triangle, right? Because they're both representing radii. If you really want, you can label it R and R. Okay, BD they told me was 20, all right? DC they told me was 16. Okay, all right, here we go. The question also told me that ABC is a right angle, and it's a right angle at A. So this right is a right angle right there. All right. So immediately from Pythagoras, we know that AB squared plus AC squared is equal to BC squared. Well, AB, that's R, radius. And then AC, that part we don't know. That's actually what we have to figure out. And identical in that form, AC squared. And then BC, well, that's just 36. So it's 36 squared. So immediately we can tell that AC squared is going to be 36 squared, which is 1296 minus R squared. So that means if I can figure out the value of R, I've pretty much solved this question. So let's try to figure out the value of R. I don't think that should be that hard. So at this point, I drew this perpendicular from A down to the base there. And that's going to help us a lot. And that's a perpendicular, so that's a right angle right there. And I hope you guys remember there's a property that if you have an isosceles triangle, right, this is the same as that size, isosceles, and if you drop a perpendicular down to the bottom, it splits the bottom into halves, basically equals. So that means that this is going to be the same as that. Okay, all right, so let's do a little bit of labeling here. We'll call this segment X from here to here, and we will call the altitude H for height. Okay, so from this triangle right here, this little triangle in there, using Pythagoras, we get that x squared plus h squared is equal to r squared. All right, and therefore we've got h squared is equal to r squared minus x squared. Okay, now we're going to do the same kind of thing, but over on this triangle here, this little guy right there, using Pythagoras there, we have h squared plus this segment right here, which is essentially 36 minus x squared is equal to the hypotenuse of that triangle, which is AC, all squared. Okay, well, this h squared is this guy, so we can just sub that in, r squared minus x squared. And then we've got this 36 minus x all squared, and that's equal to AC squared. But AC squared we just got over here. 1296 minus r squared. All right, let's expand this out. This gives me r squared minus x squared plus 36 squared minus 72x plus x squared is equal to 1296 minus r squared. Okay, some good news here. These guys go, and this is the same as that. And then if I bring this r squared, I get 2r squared, and bring the other guy over, I get 72x. Divide through by 2, r squared is equal to 36x. All right, great. Well, as I had illustrated here, this is going to be x, and therefore this is x. So that means this guy over here is x. That perpendicular basically cut that 20 in half. So that basically means that 2x is equal to 20, and therefore x is 10. So that means r squared is equal to 36 times 10, which is 360. And there we go. We are pretty much at the final step right here. All we needed to do was figure out r squared, and we just did. 360. And 1296 minus 360 is 936. And that's the answer to number 7. Determine all pairs of integers xy which satisfy the equation 6x squared minus 3xy minus 13x plus 5y is equal to negative 11. Well, let's see if we can get one variable in terms of the other. So we got 6x squared minus 13x plus 11. And let's put all the y's on the other side. 3xy minus 5y. Factor out the y, and we get 3x minus 5. And of course this side doesn't change. And then we can just put everything in terms of y. 6x squared minus 13x plus 11 over 3x minus 5. Now, we can easily sort of make a table and kind of plug away values, but the only problem with that is how long do you keep going? You don't know. You could go on forever here. So we got to somehow manipulate this to make our life easier. And we can do that without too much problem. You just go back to your very, very basic division skills. Let's do that and try to make this equation a little bit nicer. Well, 3x minus 5 goes into this. How many times? Well, let's see. I believe this will give me 2x, and if I multiply that by this guy and this guy, I will get the following: 6x squared minus 10x. Okay, let's subtract 0 minus 13x minus 10, so that's minus 3x. And then, of course, this is just a 0, so that's 11 minus 0, which is just 11. Okay, what's next? How many times does this go into this? I think if I put a negative 1, that will help. Negative 1 times 3x is minus 3x. Negative 1 times negative 5 is plus 5. Okay, so this becomes 0, and then 11 minus 5 is plus 6. So I deduce that our original equation can be written, this guy right here, can be written as 3x minus 5 times 2x minus 1 plus 6. That was this guy right here. I just made it into this format. And if you remember, our denominator at the bottom was 3x minus 5. So I just put the 3x minus 5 here. And that is equal to y. Correct? So we can break this up a little bit. We can put the 3x minus 5 times 2x minus 1 all over 3x minus 5. And then the 6 over 3x minus 5. And that is equal to y. Now something cool happens is that this cancels with that, right? Those two cancel. So all you're left with is 2x minus 1 plus 6 over 3x minus 5. And that is equal to y. Now when you try to make your xy list, we have limited options, so it won't take as long when you put it into this format right here. Okay, so the only way y will be an integer is if this is an integer. And the only way that will be an integer is if this is divisible by 6. So the only options we have are 6, 3, 2, 1. And of course, it didn't say positive, right? I think it just said integers. Yeah, just integers. So it could be negative as well. So that means this could also be -6, -3, -2, -1. So that means we only have 8 possible choices for our calculations. And you guys can do all those. I'll just give you the ones that work. When 3x minus 5 is set as 1, right here, it'll work. It'll give me 3x is equal to 6 and x is equal to 2. And that will give me a value of y, if you put this all in, 2 times 2 minus 1 plus 6 over 1. And that's what? 4 minus 1, 3. 3 plus 6 is 9. So there we go. There's one value. And then the other value that works in terms of giving us integer solutions for both x and y is when you set 3x minus 5 equal to -2. And the other ones will not give you integer values. And like I said, you guys can do that on your own. So you set 3x minus 5 is equal to -2. And that gives me 3x is equal to -2 plus 5, which is 3, and therefore x is 1. And then when you sub it back into this equation to get a value of y, it'll be 2 times 1 minus 1 plus 6 over -2. And that's what? 1 minus 3, which is -2. So there you go. Those are my only pairs. 2, 9, and 1, -2. If the log of 1944 to the base 2n is equal to the log of 486 root 2 to the base n, compute n to the power of 6. Okay, so we've got to use some log rules here. And this is equal to this. So let's just say that that is equal to a. So that means that 2n to the power of a is equal to 1944. And it also means that n to the power of a is equal to 486 root 2. Okay, using log rules, this a comes out front, but let's just break it up into 2 to the power of a, n to the power of a first. I think that will help a little bit. And then n to the power of a is right here. So we can make a very quick substitution. 486 root 2 is equal to 944. Okay, so now we can just isolate 2 to the power of a on one side and then bring this 1944 over 486 root 2. And I believe that 1944 divided by 486 is 4. So that's just 4 over root 2. If you rationalize the denominator by multiplying top and bottom by root 2, you get 4 root 2 over 2, and that's just 2 root 2. Okay, so this is equal to 2 root 2. Great. All right, things are looking up a little bit for us. Remember, let's just keep our eye on the prize. They want us to figure out n to the power of 6. Let's not forget what we actually want to do. Okay, so we boil it down to 2 to the power of a is equal to 2 root 2. Okay, now let's bring logs back into the equation. Let's take the log of both sides. 2 to the power of a is equal to the log of 2 root 2. And remember, I'm not putting in any base here. That automatically means it's base 10. And you guys know that if you don't write in a base, it's base 10. Okay, using log rules, this a comes out front. So we got a log of 2 is equal to the log of 2 root 2. And then we can isolate for a, log of 2 root 2 over the log of 2. Like that. And then there's a rule. I'll write this rule out. If you have the log of b over the log of a, that is equivalent to the log of b to the base a. So we implement that rule to this guy right here. So that means a is equal to the log of 2 root 2 to the base 2, using that rule. Okay, at this point, I am going to change that 2 root 2 into exponents. So 2 root 2 is 2, and then root 2 is 2 to the half, right? So it's 2 to the power of 1 times 2 to the power of a half. If you combine that, it's 2 to the power of 3 over 2. You're using exponent laws. So this is 2 to the power of 3 over 2. Now again, using log rules, we can bring this guy out front. So it's 3 over 2, the log of 2 to the base 2. Well, the log of 2 to the base 2 is just 1. So that means this is just a is equal to 3 over 2. There we go. Now, remember our prize was trying to find n to the power of 6, this guy right here. Okay? Well, recall all the way up here, n to the power of a was 486 root 2. So that means n to the power of a was 486 root 2. A we just figured out was 3 over 2. 486 root 2. And they want n to the power of 6, right? So we can get that by taking this to the 4th power, I believe. Yeah, if we take it to the 4th power, it'll make it into a 6. Because 3.5 times 4, well, 3 over 2, sorry, over times 4. 1.5 times 4 is 6. So this becomes n to the power of 6. And then this is 486 to the power of 4. And that's it, really. I think this is the answer. This is correct. Now, whether they accept it in this format or not, I don't know. If you want, you can make it into a more pretty format. I don't think it's necessary, but let's just say you want to do that. 486, I believe, is 2 times 3 to the power of 5, and root 2 is, of course, 2 to the exponent a half, all to the power of 4. So this will be 2 to the power of 4 times 3 to the power of 20 times 2 to the power of 2. And if you combine that, it'll be 2 to the power of 6 times 3 to the power of 20. Whatever, I mean, this is perfectly correct. So in either way, that's the value for n to the power of 6. Determine the sum of the angles AB, where A and B are between 0 and 180, and sine A plus sine B is the root of 3 over 2, and cos A plus cos B is the root of 1 over 2. All right, well, a lot of trig identities are probably going to be involved, but one that sort of immediately comes to mind is this one, right? The most famous one, sine squared theta plus cos squared theta is 1, because I can kind of see that if you squared these, you're going to be able to get something like that. So let's do that. Let's square it. So if I square the first one, it'll be sine squared A plus 2 sine A sine B plus sine squared B, and that's going to be 3 over 2 when you square it. Well, this plus this is going to be possible, but you have to have the same angle though, so I can't do that just quite yet because I have A and B, and also I don't have a cos. No problem, let's do the square of that side. So that's going to be cos squared A plus 2 cos A cos B plus cos squared B is equal to 1 over 2. Okay, now I think we'll be able to help solve this question. Now let's add these guys, and when you do, on this side you get 3 over 2 plus 1 over 2, which is 2. And when you add these guys, you're going to be able to get a lot of good stuff here. Sine squared A plus cos squared A, these guys, that's just 1. Sine squared B plus cos squared B, that's just 1 according to this identity. And then you've got this stuff in here. So we've got 2, and factor out a sine A, sine B, plus a cos A, plus times cos B. Okay, well 1 plus 1 is 2, and that's 2, so that just cancels. So all you're left with is just this, sine A sine B plus cos A cos B is equal to 0, because the 2 will be able to be canceled out as well. All right, so this is pretty much what you're boiled down to. Now you have to bring in some of the lesser known trig identities, and some of these are a little bit more difficult to remember. This guy right here, the identity is cos A minus B minus cos A plus B all over 2. This one right here, that identity is cos A plus B plus cos A minus B all over 2. And remember, this is all equal to 0. Well, the good news is some of these things cancel out. This guy cancels. This cancels with that. So all you're left with really is just cos of A minus B. It's 2 of it all over 2, but then the 2's cancel. And that's equal to 0. So just if you remember the simple graph of a cosine, it's easy to figure out just from the graph alone. You don't need a calculator. This is 90 degrees and this is 180. That it's 0. The cos of something is 0 in this range when that something is 90. So that means A minus B is equal to 90 degrees. Okay, but the question wants us to figure out A plus B, the sum of the angles. They want A plus B, they don't want A minus B. Okay, well, we made some progress by finding A minus B, but we still got to keep going a little bit. Okay, well, from this A minus B is equal to 90, we can deduce that A is equal to 90 plus B. And then what we can do is use that and sub it back into one of these. So whichever one you want, I'll just choose this one right here. I think it should be fine. So that original equation, which was cos of A plus the cos of B is equal to the root of a half, we're going to substitute this. We're going to put in 90 plus B. And I think that should help figure out what is A and what is B, and then we can add them. All right. Well, the trig identity, to expand that, was cos 90 cos B minus sine 90 sine of B. And then this is just a cos B, and that is equal to the square root of a half. Well, cos of 90 is 0, so that cancels out. And sine of 90 is 1, so this just becomes the sine, negative sine of B plus cos B. Now at this point, what I'm going to do is I'm going to square both sides. And when I square both sides, I will get cos squared B minus 2 sine B cos B plus sine squared B, and that is equal to a half. Cos squared B plus sine squared B is 1. So that's 1 minus 2 sine B cos B is equal to a half. All right, we're getting somewhere here. Let's put everything on one side. So this becomes 1/2. This becomes 2 sine B cos B. And now if you remember the double angle identity, this, in a very nice way, becomes this, sine of 2B. That's the double angle trig identity, and that's a half. So now we're pretty much done. The sine of something is a half. Well, when is the sine of something a half? If you remember the sine graph, if I remember the sine graph, well, it's a half for many values, but let's just go with something simple. This is 1, right? So a half is about here. It happens at 30 degrees. So that means this is 30 degrees. So 2B is 30 degrees. That means B is 15. And if B is 15, and we knew from previously that A minus B is 90, that means A would be 90 plus 15, which is 105. And therefore, finally, A plus B will be 105 plus 15, which is 120. The answer for number 10.